Hi guys, today we are solving rational equations, and if you look right here in red, the first equation we're going to do is 3 over x plus 1 equals 9 over 4x plus 5. This might look familiar, it's a proportion, and we're going to work on it the same way you used to in the past. You'll multiply the numerator of 3 times 4x plus 5 equals the numerator 9 times the other denominator x plus 1. And then from there, this should look pretty familiar. You distribute the 3, you get 12x plus 15. You distribute the 9, you get 9x plus 9. And then solve accordingly. Subtract 9x from both sides, subtract 15, divide by 3, and you get a solution. Big thing with this stuff you really have to check. You'll see why in a couple days. When you plug in -2, you do get a true statement in this case, but not a lot of times you do, so you always have to check. And make sure that you agree with me. Maybe I made a silly error. All right, let's look at example 2. Example 2 says 5 over x plus 7 over 4 equals -9 over x. And that's definitely more challenging because you have different denominators and it's not just a fraction equaling a fraction. So for this case, you have to look at your denominators and we've got to cancel them out in order to do any math. So we have an x, a 4, and an x. So your least common denominator is 4x. You're going to multiply everything by your least common denominator, each fraction. Okay, and then let's see what happens. Pause the video, watch, try to do the problem. All right, so when you do the math, you end up getting 20 plus 7x equals -36. Because what happens here is the x's will cancel and 4 times 5 is 20. What happens here is the 4's will cancel and then x times 7 is 7x. And then lastly, the x's will cancel and 4 times -9 is that -36. Then this is a simple equation to solve. You're done in 2 steps and you get -8 for your x value. And then you do have to check plugging in -8 into the original problem. And it does get a little tricky because you don't have like denominators. We have to remember that it's not a -8 here. It's the same thing as just putting negative in front. So you have -5 eighths plus 14 eighths. That's 9 eighths. We have to also think, a negative divided by a negative, that's a positive. That does check out. So now, number 3, I've got 1 minus 8 over x minus 5 equals 3 over x. There's no denominator here, it's just like a 1. But I'm looking at these two, what's my least common denominator? Well, it's when you multiply them, x times x minus 5, and then you need to multiply everything by x times x minus 5. When you do that, thank you. When you do that, 1 second, I can't pause this. All right, so when we multiply everything, x times x minus 5 times everything, you get x times x minus 5. Over here, what cancels? There's my marker. X minus 5 cancels, and I'm left with x times 8, that's 8x. And then over here, I have an x in the numerator and x in the denominator, so I have 3 times x minus 5. Distributing that gives me 3x minus 15 right there. So then when you have this quadratic equation, you're going to see that when you distribute here, you get x squared minus 5x. You have a quadratic equation, so you're going to need to have everything equal to 0 in order to solve quadratics. So undo a positive 3x by subtracting 3x. Undo -15 by adding 15. So we have a lot going on now. So now I have x squared minus 5x, that -8x from here, minus 3 more x gives us -11x. And then when I add 15, it's a plus 15. When I combine like terms here, I still have more to combine. I get -16. Now this is the step where we are ready. We're set up. X squared minus 16x plus 15. We have to think what multiplies to 15 and adds to -16. So that factors to x minus 15 times x minus 1. And then solve for each one of these. X then equals 15 and x equals 1. Plugging in 1 to check, you do get a true statement. Plugging in 15 to check, you do get a true statement. Make sure that you check. Make sure it does.